So yesterday's video focused on getting common denominators, but we had to factor first. So this video is going to be 3 short problems just to go back and review those same concepts. If you look at these denominators, you're going to notice one of your denominators needs to be factored. When we factor that denominator, it's going to help us see what our denominators have in common. This one is a difference of 2 squares, so I'm going to take the square root of 4, and it factors to be x plus 2 and x minus 2. So I just changed that denominator. It's the same thing, it's just written a different way. So that denominator is x plus 2 and x minus 2. If I look at my other denominators, I see that they already have something in common. This one has the x minus 2. It needs the x plus 2. What I do to the bottom, I have to do to the top. Working in reverse order, the first denominator has the x plus 2. It needs the x minus 2. So every denominator should have x plus 2 and x minus 2. Double check to make sure that they are all the same, and if they are, you can cross them off and just focus on your numerators. It helps to rewrite those numerators so that you do not miss anything. Notice on the right side we didn't have to do anything to 10x minus 2 because their denominators were already fixed. So at this point, we are just going to distribute, and if you want to use the box method, you can, but distribute your 7. So 7x minus 14. That is a positive 5, so let's distribute positive 5. 5x plus 10. On the right-hand side, there is no work that needs to be done. So on the left side is the side that's a little bit congested, so let's clean it up. So looking for like terms, 7 plus 5 give us 12x. My other like terms are negative 14 and 10. When I combine those, I get negative 4. Bring down the right side. So I've cleaned it up as much as I can on either side. Now I can begin to move things from one side to the other. I'm going to start with the 4, but you can start with the x's if you want to. That leaves me with 12x, 10x, and positive 2. I still have like terms, so I'm going to move my 10x. So 12 minus 10 is 2. The 10's cancel, and I'm left with 2 on the other side. My last step is to undo that multiplication. So my answer is x equals 1. We're going to look at example 2. These were a little bit easier yesterday. They're a little easier to recognize because you see a trinomial. I can factor that trinomial, and it will help me see what my common denominators should be. So multiplying to get negative 15, adding to get 2, that should be positive 5 and negative 3. So I'm going to change this denominator. I'm just going to rewrite it so that it says x plus 5 and x minus 3. When I do that, I should see something in common with my other denominators. So I'm going to work backwards again. X plus 5, it needs the x minus 3. What I do to the bottom, I must do to the top. My first denominator has the x minus 3. It needs the x plus 5. Every denominator should have x minus 3 and x plus 5. Double check before you move ahead. Since they all have x plus 5 and x minus 3, you can cross them off and just work with your numerators. As I mentioned in the last video, it helps to go ahead and rewrite that so that you do not miss anything. Again, on the end, negative 2x plus 9 did not change because the denominators were already fixed. So we can go ahead and distribute on this left side. Distributing 1 is not going to change anything. Be careful here with your x's. X times x is x squared. X times negative 3 is negative 3x. I can bring down the right side. On the left side, I have some like terms that I need to get together. So 1 minus 3 is negative 2x. And you may already notice what's going to happen because you see an x squared and an x. So I'm going to start moving things from side to side. If I start with my x squared has nothing else in common, so I can't move it. If I move the 2x, they're going to cancel. I get 0 and 9. So in this case, my x is canceled, which looks funny because normally that does not happen. But I still have my constants. So if I move my 5, 5's canceled. I'm left with x squared equals positive 4. So I was thinking at first we might have to factor it, but in the end, I don't have an x, it's just an x squared. So we can solve it as normal. It does say x squared, so when we take the square root, we will get a positive and a negative 2. One more example. Example 3, again, you see that you can factor using the x method. Multiplying to get 16, adding to get 10. So negative 8 and negative 2. I'm going to change how that's written to x minus 8 and x minus 2. Again, the whole purpose in that is so that you can see the other two denominators will have something in common. So this denominator has the x minus 2. It needs the x minus 8. The first denominator has the x minus 8. It needs the x minus 2. Every denominator should have x minus 8 and x minus 2. If they do, you can cross them off and just look at your numerators. So I'm going to write down exactly what I see in my numerators without doing any math yet. Now I'm going to start solving. So let's distribute. X times x is x squared. X times negative 2 is negative 2x. That is a positive 6, so signs should not change. Positive 6x and 6 times negative 8 is negative 48. The right side stays the same. So on the left-hand side, we're going to combine any like terms that you see, and I see some x's. So negative 2 plus 6 is 4x. I've combined my like terms on each side. Now I can start moving them from one side to the other. I'm going to start with my x squared. And when I do, you should see that they cancel. So I'm left with 4x minus 48 equals 0. And we've discussed the only time that really that should happen is when you have to factor. So we're actually going to have to move something back over. If you're working ahead, you may have done this in a different order, and that's fine. So to solve this, I actually need to move my 48 over. So I'll have 4x equals 48. So to solve it, divide by 4, and you get that x equals 12.